It is day 20 in Algebra 2, and we are talking about probability, same as yesterday. And today we are kind of looking at this little do now assignment together as a class. So let me just get this on the right setting, zoomed in. Okay, now before we start doing these, one thing I want to ask you all is whenever we're finding probability, there's three different ways that we can express that probability. There is a fraction. What are the other two? Yes, a decimal. And the last one, a percentage. Going in that order of finding the fraction first, then the decimal, then the percentage. I find the percentage helps us understand what exactly that probability means a little better than a fraction or a decimal might. So that's kind of why we go through that process of converting. So let's just look at the first question together. I drew a little picture of a spinner up at the top, and you can see there are 8 numbers on the spinner. We're going to assume that all these sections are the same size. So my question is, if you spin the number wheel one time, what is the probability of landing on the number 5? So let's think through this together. How would I represent that probability as a fraction? What would go on top? What would go on bottom? Say it again. 8, is that what you said? 8 on the bottom? Okay. And then we're trying to come up with the probability of spinning a 5 on this number wheel. So how many times is 5 on this number wheel? Just once. Just once. So the number on top tells us how many times can that happen? Well, there's only 5 once. So how many, how do I want to label that? How many times do we see 5? That's where we get the top number. And how did we get 8? Yeah, there's 8 spaces, there's 8 possible outcomes. So that bottom number tells us how many options are there. So total number of options. So the probability of spinning a 5 is just 1 out of 8. There's 8 possible numbers we could land on. There's only one 5. So how could we write that as a decimal? What would we do? Yes, we're just going to divide. We will do 1 divided by 8. So let's see what that gives us. 1 divided by 8. And I get a decimal of 0.125. So I'm going to write that over here. 0.125. And how do I turn a decimal into a percentage? That's right. I'm going to look where my decimal is, that little dot, and I'm going to move it over 1, 2 spaces. So instead of the decimal being in between the 0 and the 1, where will the new space be? Good, between the 2 and the 5. So our percentage would be 12.5%. So there's a 12.5% chance that when I spin this wheel, we'll land on a 5. And that would be our probability. Okay. So now let's look at number 2. What is the probability of spinning an even number? So to answer this question first, we need to know what is an even number. What is an even number? Y'all know?
2, 4.
Yes, 2, 4, 6, 8. It's numbers that can be divided by 2. So if I have all of these numbers, I've got 1, 2, 3, 4, 5, 6, 7, 8. How many of these are even? 4. I have 2, 4, 6, and 8. These are all even numbers. So there's 4 evens. So when I want to think about writing the fraction for the probability, here, let me publish this. Okay, so I know that I have 4 even numbers, and I want to write a fraction to say what is the probability of landing on an even number. So I look at my little format. I need to put the top number to tell me how many times do we see an even number, 4, and the total number of options. So what number goes on top of the fraction here? 4. I could spin an even number 4 different times. What would go on bottom? 8. And that number 8 does not change because there's still 8 options total. So 4 out of 8 would be our fraction here. Could I simplify this? I could divide both of these by what? By 2. I could do that. So I'm going to divide by 2, and now I have 2 over 4. Could I simplify again? I sure could. I could divide by 2 another time. And I'll get 1/2. 1/2. So what this tells me is when I spin that wheel, half of the time I'm going to land on an even number. So what would my decimal be? Yes, 0.5. So I just type 1 divided by 2, and I get 0.5. Now, whenever I translate this to a percentage, what would I do in the case that I don't have 2 numbers to move 2 spaces?
Add a 0.
You just add a 0. Yes, if there's no number there, you put a 0 in its place. So what would our percentage be? 50%. Good. There's a 50% chance we'll land on an even number. All right. So before we move on to number 3, do we have any questions about how we got the answers for 1 or 2? Or is it making sense? It seems to be making sense. The first 2 are pretty straightforward. So let's look at number 3. Now we're looking at 2 separate events. Now my question is, if you spin the number wheel twice, what is the probability of spinning a 5 and spinning an even number? So before we can answer this, we need to think about what we were talking about yesterday, where we have 2 different types of events. We could have independent or we could have dependent. So let me grab my notes from yesterday and let's look at the difference between those 2 and decide what we have going on here. So I'm talking about spinning a number wheel 2 times. Whenever I spin the wheel the first time and then I spin it again, will whatever I land on the first time affect what I might land on the second time? It will not affect it. It's not going to affect it. So if the first event does not affect the second event, do we have independent or dependent? We have independent events. These are not going to affect each other. So we can use this formula here. To find out the probability of both of these things happening, we're going to find the probability of the first one and multiply it by the probability of the second one. So, looking back at the problem, here's my two probabilities I need to find. The probability of spinning a 5 and the probability of spinning an even number. Now, the beauty of this is we already did both of those. We got 1/8 for the probability of spinning a 5. We got 4/8, or 1/2, for the probability of spinning an even number. So what would I do to find the probability of both? We're going to multiply them, absolutely. So spinning a 5, all right, 5, we said it was 1/8. The probability of an even number, we said, was 1/2. So we're going to multiply these two fractions. 1/8 times 1/2. And when we multiply a fraction by another fraction, how do we do that? Just straight across, right? So 1 times 1 is what? It's just 1. 8 times 2, 16. So my fraction is 1 out of 16 times. Will both of these happen? What would my decimal be? 0.0625. Perfect. 0.0625. And my percentage? 6.25%. Perfect. I'll move it 2 spaces. That puts my decimal in between the 6 and the 2. So I'll get 6.25%. All right. All right. So we have found the probability of two different things, and then we found the probability of them both happening together. Independent events. So now we're going to look at the last question. And this one is just like the exit ticket we did yesterday. So if you have not completed that exit ticket, this problem will be helpful. So I drew you a little picture of a bag full of buttons. And it says if a bag contains 3 blue buttons, 2 red buttons, and 4 orange buttons, what is the probability of drawing a blue button and then drawing an orange button without replacement? So what do I mean by without replacement? Yes, I'm not putting the button back in the bag once I draw one out. So whenever I find that overall probability, we're going to have a different type of set of events here. Once I take one button out, is that going to affect the probability of the next button I draw? It will affect it. So these will be dependent events. Because they are dependent, whenever we find that second probability, we'll need to think about how it affects the overall number of choices that we have. So let's start here. If I have 3 blue buttons, and how many do I have total? 9. How would I write my probability of a blue button? Yes, 3 out of 9. There's 3 blue, 9 total. 3 out of 9. Now, what is the probability of drawing an orange button? Ooh, yeah. So it would be 4, and there were 9 total. But if I took a blue button out, how many total do we have left? We have 8 left now because we did not replace that button. We didn't put it back in the bag. So that total does not stay 9. Now we have 8 total. And there's 4 orange. So to find the probability of the blue and orange without putting the blue one back, what do we need to do with these two fractions? Simplify them. We could simplify them, absolutely. We could also just multiply them, couldn't we? Then we could simplify at the end. If it makes it feel easier to multiply, which in this case it probably would, you could simplify first. What would 3 over 9 simplify to? 1/3. What would 4 over 8 simplify to? 1/2 here. All right, so I have 1/3 and 1/2. And now we just multiply those, right? 1/3 times 1/2. And once you multiply that out, tell me when you've got an answer. Perfect. 1/6. That is our probability. What would it be as a decimal? 0. You said 166? Perfect. 1, 6, and you'll see that 6 is going to repeat forever and ever and ever. We could just put a little line over the top of it, 0.16. And as a percentage, what would that be? 16%. We could also, because that 6 is repeating, we could either say 16% or 16.6 repeating percent. I would accept both answers. Both are fine. Okay, so there's a little refresher, little review on how we did that yesterday. And I'm going to give you guys a few scenarios that I want you to try working out on your own, just to make sure it's stuck. Let me see. And then we're not going to do a whole lot more other than that today. So once I give you these practice problems, after we complete those and look at them together, if you're caught up on everything from this week, you will just have a nice, easy leave early day. If not, you're welcome to stay and use your time to catch up on whatever you may need to catch up on. But before I move this, does anybody still need it? Okay, I'll go ahead and scooch it out of the way then. So we're now going to look at specifically practice problems for independent events, meaning these do not affect each other. Your total on the bottom is going to stay the same every time. So here's a few scenarios, and I'm going to title my page first. And day 20 practice problems. Okay, so I'm going to give you 4 events, and all of these events are going to be talking about the same 2 objects. We're talking about a 2-sided coin where your options are either heads or tails, and a 6-sided die where your options are 1, 2, 3, 4, 5, or 6. So all 4 problems I give you are going to be based off of these 2 items. So we want to know first the probability of landing on heads and rolling an even number. Underline the separate events. The second set of events will be the probability of landing on tails and rolling a 5 or a 6. And once I write these out, I can make copies for you guys so you don't have to write so much. Let's see. The third set of events will be the probability of landing on tails and rolling a number bigger than 1 and the fourth scenario will be the probability of landing on heads and rolling a number smaller than 5. Okay. So I will freeze my screen and I'm going to run some copies of this just because I know whenever you're looking at all of them together, it's probably a little difficult to read it from your seat. It gets a little small. So let me freeze this. All right, so you've had some time to work on these. Now let's go over them together, make sure we've all got a good understanding. So for number 1, how will I find the probability of landing on heads and rolling an even number? How will I do that? Okay, so the probability of landing on heads is 1 over 2. Perfect. And then what's the probability of rolling an even number? 3/6. How'd you know that? Yes, perfect. There's 2, 4, and 6. Those are 3 numbers that are even out of 6 total options. So we have our 2 fractions. We'll multiply them. 1 times 3 gives us 3. 2 times 6 gives us 12. 3/12 would be our fraction. What y'all get for the decimal? Perfect. 0.25. And last but not least, our percentage, 25%. Good. Good, good, good. All right. Let's look at number 2. Probability of landing on tails and rolling either a 5 or a 6. This one was tricky as I was walking around the room. Some of us struggled at first, but I think once we talked about it, we got it. So, what's the probability of landing on tails? 1 out of 2. There's 2 options. There's only 1 tails. Perfect. Now, how would I find the probability of rolling either a 5 or a 6? 2/6 is going to be the answer. Now, how do we know it's 2/6? Right. There's 6 total options on a die. 1, 2, 3, 4, 5, 6. These are our 6 options. We're seeing how many times is it possible to land on a 5 or a 6? Well, here's 5 and here's 6. That's 2 numbers. There's 2 options out of 6 total. So 2/6. So what's the probability of both of those happening? 1 times 2 is 2. And my bottom number, what'll that be? 12. So our decimal, what'll that be? Perfect. 0.16666. It goes on forever, repeating. And our percentage. Perfect. 16.6 repeating percent. If you just kept it as 16%, that is also fine. However, if we wanted to be as accurate as possible, since that 6 repeats, we know that it does exist. It keeps on going there. So, very nice. 16.6 repeating percent would be our answer here. Okay, let's look at the third one. We already know the probability of landing on tails, 1/2. We just did that above. Now, how do I find the probability of rolling a number bigger than 1? Right, I'm just going to count how many of these numbers are bigger than 1. Well, 1 is not bigger than 1. 2 is, 3 is, 4 is, 5 is, and 6 is. That's 5 options that are bigger than 1. So 5 is my number on top. How many options are there total? Still 6. All right. So now, what's our overall percentage of both of these happening? Or not percentage. Let's get the fraction first. What will that be?
5/12.
Yes, 5/12. 1 times 5, 2 times 6. What's our decimal? 0. 0.41. Okay, hang on. Let me just get that on my calculator too. 5 divided by 12. Oh my gosh. There. 0.416 repeating if we wanted to be super precise, but I'm fine with 4, 1. I'm going to write the 6 repeating just to be however. Okay. What's our percentage? 41%. Perfect. We could also say 41.6% repeating. 41% is still correct. I will take that too. Okay. So that is 1, 2, and 3 done. Last but not least, number 4. What's the probability of landing on heads? 1/2. And how will I find the probability of rolling a number that is smaller than 5? Yeah, let's look and see how many of these numbers are smaller than 5. Well, 6 is not, 5 is not, 4 is smaller, 3 is smaller, 2 is smaller, and 1 is smaller. So how many numbers are smaller than 5? 4. So that's our number on top. And how many options are there here? Still 6. So 1 times 4 is 4. 2 times 6 is 12. What's our decimal? 4 divided by 12. Oops. Yes, 0.3 repeating is what I got. Okay. You could make 4 out of 12 smaller fraction. Is that what you said? You absolutely could. What would that be simplified? Yeah. So you could get 2/6 by dividing by 2, divide by 2 again, you could get 1/3. This step is not necessary, but sometimes when you do simplify your fraction, it just makes it a little bit easier to do the math later. So good to know. That's also correct. What would our percentage be? Almost. 33%. So I have right here, this one is weird because we're only given one space, but because it's repeating, would 30% be correct? Technically, no, it wouldn't. If I have 0.3 repeating, it really means that there's a bunch of 3s afterwards. So if I move 2 spaces, my decimal becomes a percentage of 33.3 repeating percent. And that would be my percentage there. Okay. Any questions about any of that? Do we feel like we have a better understanding about this than yesterday? I feel like y'all do. What it seems like to me. I think that's good. Okay, that's all we're doing today. So if you have nothing to get caught up on, tomorrow what is due is the Unit 1 quiz, the practice quiz, and the Day 19 exit ticket from yesterday. If you've done all 3 of those things, then you are free to go. You're all caught up. Feel free to come and talk to me if you have questions about anything that we have due or anything we've done this week. But other than that, I hope you all have a very nice weekend.